So we're going to come back to trigonometry here in this section to talk about the derivatives of trig functions. And we're going to start simply with the derivatives of sine of x and cosine of x. We're just going to look at those two to start. If I want to take the derivative of sine of x, the derivative of sine of x is actually just cosine of x. And if I want to take the derivative of cosine of x, the derivative of cosine of x is negative sine of x. So there's this very cool cyclical relationship between sine of x and cosine of x when it comes to derivatives. If you take the derivative of sine of x enough times, you'll actually get back to sine of x, which I think is just kind of a really cool property to have. And if you look at the graph of sine of x and think about the slope of the tangent lines at different points, you can actually see that the derivative of sine of x is cosine of x just by thinking about the slopes of the tangent lines. And I'm going to post some videos or some resources that show that, just because I think that relationship is really, really cool to see on your own. And we're going to be using the derivatives of these trig functions along with some of the other derivative rules that we've been learning. So we're going to add in the product rule and the quotient rule and the power rule and all of those. In every single section here, we're just going to be adding in a little bit more, so our functions are going to be a little bit more complicated in every single one of these sections because we have more rules to work with. So let's start with part A here. Part A says, let's go take the derivative of 2x squared plus e to the x cosine of x. Well, if I want to take the derivative y prime, derivative of 2x squared, I know that's just a power rule, that's just 4x, so that's really not a problem for us. Plus, I want the derivative of e to the x times cosine of x. Now notice I said e to the x times cosine of x. I really want to emphasize that word times because I'm multiplying these two functions. I think it's something that's really easy to overlook. We're multiplying these two functions together, and when we write it like that, I think the hint I'm trying to give is a little bit more obvious. This is a product rule problem. I'm multiplying e to the x times cosine of x, so this is a product rule problem. So my product rule, just in case we need to lay it out off to the side, remember the product rule says f prime times g plus f times g prime. So if I call this function f and I call this function g, derivative of e to the x, that's my f prime, so derivative of e to the x, that's just e to the x, times g, I'm going to leave cosine of x alone, plus f, so e to the x, so that was this guy right here, times g prime, derivative of cosine of x. Well, we said derivative of cosine of x, that was negative sine of x. So g prime is negative sine of x. And then I can simplify this a little bit. I can say, well, this is 4x e to the x times, plus, what did I forget? Oops, no, I forgot my plus sign right here. So 4x plus e to the x cosine of x. E to the x times negative sine of x, that'll be negative e to the x sine of x. And we can't really simplify this a whole lot more, so I think that's a good place to stop for our solution. Next up, part B, I have f of x equals sine of x times cosine of x. So I look at this, I see sine of x times cosine of x. Again, I said times. That should hopefully emphasize that we need, again, the product rule. So I need the product rule. I need f prime times g plus f times g prime. Maybe I'll call this function f and I'll call this function g. So when I take the derivative of f of x, derivative of sine of x, that's f prime, so derivative of sine of x, that's cosine of x, times g, derivative of, or excuse me, I will leave cosine of x alone, so g is just cosine of x, plus f, that's sine of x, times g prime derivative of cosine of x, that's negative sine of x. cosine of x times cosine of x, I'll have cosine squared x. And then sine of x times negative sine of x, I'll have negative sine squared x. And this seems like a good place to stop for our solution. I think that might be a double angle formula. I don't remember off the top of my head. I am not going to ask you to memorize all that many trig identities, so if you don't remember your double angle formulas or your half angle formulas, don't stress too much about those. You may see my math lab simplify those a little bit farther than I think is necessary, but I'm going to try and pick problems where you don't have to use those. The one formula I do think is worth knowing while we're on the topic is I think we should know the Pythagorean identity sine squared x plus cosine squared x is equal to 1. I always tell my students, if you're going to know one trig identity, this is the one to know. This is the one that I expect you to know. And then we can come up with the other Pythagorean trig identities by dividing this equation by sine squared x or cosine squared x. So it's a really nice, easy way to kind of remember all three. So I'm actually going to be using that here when I take the derivative of y equals tangent of x. You might say, well, gee, Mr. Huber, I want to help you out. I want to tell you the derivative of tangent of x, but you didn't tell me the derivative of tangent of x. All I have is sine of x and cosine of x. But remember that tangent of x, I can rewrite tangent of x as sine of x divided by cosine of x. I may not know the derivative of tangent of x, but I know the derivative of sine of x. I know the derivative of cosine of x. And I know how to use my quotient rule. So let's go just use the quotient rule here. So y prime, my quotient rule, says low, so that's going to be cosine of x, d high, derivative of sine of x, that is also cosine of x, minus high, that's sine of x, d low, derivative of cosine of x, that is negative sine of x, divided by cosine of x squared. So cosine of x times cosine of x, I should have cosine squared x. Here I have a negative times a negative, that'll be a positive, so plus sine squared x divided by, we don't usually write this as cosine of x squared, more commonly we'll see that as cosine squared x. And I want to simplify this now. And there's a number of different ways you could do that, but I look at this, I see cosine squared x plus sine squared x. Well, that sounds an awful lot like sine squared x plus cosine squared x. So I can take that out and replace it with 1. So this is equal to 1 over cosine squared x, which we could probably leave our answer there, but it would look a whole lot nicer if we didn't have division. I know that the reciprocal of cosine of x is actually secant of x. So this is secant squared x. So the derivative of tangent of x is actually just secant squared x. And this is a really cool exercise because you can actually come up with the derivatives of all of your other trig functions if you just know the derivative of sine of x and cosine of x. Because I can use trig identities, to rewrite all of those other trig functions. So if I'm working with, say, cosecant of x, I know that that's really just 1 over sine of x. And then I can use the quotient rule on that right-hand side. I can, or I know, that the function secant of x, that's really just 1 over cosine of x. And I can use the quotient rule on that right-hand side. I know that cotangent of x, that's really cosine of x over sine of x. And then I can, again, use the quotient rule on the right-hand side. So oftentimes I'll joke with my students, I'll say, I don't even know the derivatives of the other ones because I just know sine of x and cosine of x. I can figure out the rest using the quotient rule. And I joke, but that's actually 100% true. Like, you can, well, I know the derivatives of my other functions, but you can find the derivatives of all of your other trig functions if you just know the derivative of sine of x and cosine of x. So if you come into a situation where you blank out on an exam, you know the derivative of sine of x and cosine of x, but perhaps you forgot the derivative of, secant of x, you can always rewrite that as 1 over cosine of x and then use your quotient rule. I think that's a really good exercise for you to take a look at, so I'm going to leave those 3 as kind of practice problems for you to do. But I do think that it's a really good practice with your quotient rule. It gets you nice practice with derivatives of sine of x and cosine of x, and in some of them it gets you nice practice recognizing that Pythagorean identity, that one that I think you should know. But I will give you the other derivatives of these trig identities here before we end this video. So we said the derivative of tangent of x, that was secant squared x. The derivative of secant of x, is actually secant x times tangent x. Derivative of cotangent of x, that is negative cosecant x times cotangent x. And the derivative of cosecant of x, and actually, hold on. Oops. I said I know my derivatives. I must have lied because I messed that one up. Derivative of cotangent of x, that is actually negative cosecant squared x. My apologies. And then the derivative of cosecant of x, that is negative cosecant of x cotangent of x. So these would be good to memorize. I think it would be helpful to know all of them, but remember that you can always fall back on rewriting your trig function in terms of sine and cosine, and using your quotient rule you can always come up with all of these derivative rules on your own if you ever just happen to forget one of them, or perhaps mix one of these 2 up like I did. So I mixed those 2 up. So take a look at some of these practice problems. We will look at some more derivatives in the next video involving these other trig functions.